cow.
Wow.
Welcome back. I'm awake. Are you awake?
I think
Did you put it in the description? Turn volume down.
All right. Warning. Volume alert. So, I'm doing notes today on a separate sheet of paper because with the 3x3 systems, like, it makes a big mess. We need a lot of room. So if you don't have lined paper, go ahead and get up now and grab some. If you happen to be sitting up here next to me, I've got a few extra sheets. I'll be happy to.
Can I do it on the back?
Yeah, or you can do it on the back. That's fine.
Miss my pen died.
Oh no. A moment of silence.
Good.
For the pen.
It's still there. I still see E.
No tiene E.
Freaking liar. What is that?
Ew,
Battery?
oh, it's not
You
wet.
still have all this right here.
Dry bean. You should add more.
This is the system that I would like to do today.
Guys,
This one, right?
Yeah.
I'm gonna use a cutter for you.
Yeah.
That's easier.
This one.
All right. So the trick for 3x3. The first thing you need to realize is that our solutions for the 2x2 were called ordered pairs. There were two parts. There was a value for x and a value for y. In a 3x3, 3 variables, 3 equations, we are going to have 3 different parts to our solution. And the solution will be called an ordered triple because the numbers have to be in order, x, y, z. And there's 3 of them. So we don't want to call this group of 3 a pair. That would be weird. So we're going to call this group of 3 a triple. Less weird. The rules are the same. Pick one of the equations to solve for one of its variables.
The first one.
The first one, okay. And what are we solving for? You get to pick x. All right, so I'm going to solve this equation for x because you told me to. All I did was subtract 2y from both sides, and then I added 5z. Now that I have this one equation solved for one variable, I'm going to substitute this in to both of my other equations. What this will do for me is it will turn this system of 3 equations into a system of 2 equations that then I get to do all of my 2x2 stuff. Okay? So I solved it for x, and now I'm going to take that big mess of stuff, and everywhere I see an x in the other 2 equations, I'm going to substitute. I'm numbering my equations just so that you can kind of keep track of where things are. There's my substitution into equation number 2. And then here's my substitution into equation number 3.
That's so long.
It really is. The 3x3s are annoying to do by hand, not because they're hard, but because there's a lot to do.
Are you still gonna make us do them?
And a lot, yes.
What did she ask?
She asked, are you still going to make us do them? And the answer was yes. Yes, I am. Sad face.
We're all doing it.
Okay. Shall I throw some color on here so you can see what I did?
Yes, please.
All right. There's X, and I did this. See it? All right. I'm going to now simplify each one of these down a little bit. So I have y and z on one side, and then I'm going to shove the whole numbers that don't have variables next to them on the other. Okay, I'm not solving for any one variable in particular yet. So I'm gonna do some distribution, then I'm gonna do some like terms, and then we're gonna see where we're at.
I pretty much said it.
I did a lot in that last step.
That's the 7Z, right?
Yes.
Oh, I thought it was another side. My bad.
I did a lot and I didn't show all of my work, so please let me know if I lost you on there. Read through it.
Oh, I see. You just distribute it.
Mm-hmm. I distributed and then I moved the negative 24 over to the other side so it could hang out with the negative 2.
So it'll be negative 2 minus 24.
Yes, so it'd be
Okay,
negative
I
2
thought it
plus
was-
24.
I thought it was the other way around.
No, I'm adding 24 to both sides.
Oh, okay.
All right, here's that third equation. Again, I did distribution, I combined like terms, and then I shoved the negative 36 to the other side of the equal sign. All right, and I've got some nods telling me that I added and subtracted properly then. Phew. All right, now that I have these two equations, this basically gives me a new system. And my new system is looking something like the thing that I'm writing off screen right now because I see a few of you still copying what I've done. Very slowly moving my camera so I don't get you dizzy. And there's my new system. Right here. And now I get to play the game all over again. So just like it's a normal 2x2, which of these two equations looks the easiest to solve for one of its variable? Yeah, it doesn't matter, your choice.
Wait, is that just for like one column?
Yeah, this is no problem. Yeah, she had mentioned that the first equation on my new system looks like it would be the easiest. I agree, not because there's the least amount of work, but because the numbers are smaller. Yeah.
When you're rereading the two new ones, does it have to be in the same order as the very first one, where the one that was on top has to be the one that was changed on top?
Okay, so the question is, when I'm rewriting this new system, do I have to rewrite it in the exact same order? The short answer is no. It's a great question. All right, so we're going to solve this one. What variable did you feel that it was the easiest to solve for? There's no more x in this equation. Try again.
Oh,
Y?
sorry.
Okay, that's
That was
all
an
right. It's okay. So we'll solve this one for y. Okay, I'm going to shove the 7z over. Then I'm going to divide everything by negative 2. Now I see this huge fraction. I don't want to deal with that. So what I'm going to do is I'm going to split up that division this way. And now I can handle each fraction separately. On this fraction, the negatives are going to cancel. And on this fraction, 22 divided by negative 2 is negative 11. I have a value for z now, which I'm going to substitute back in my other equation. There's a lot of back and forth on this, isn't there? And that's the only reason why these are hard, is because it feels like it's really easy to get lost. Like I'm making a big mess, you know. All right, there's my substitution. I'm going to distribute and I'm going to collect like terms and I'm going to add or subtract in things. On my first pass through, I'm going to do the distribution of that negative 10, but I'm distributing to a negative. And so instead of actually writing the result of the multiplication, I'm just going to write, hey, I have to multiply here, okay? And I'm going to turn that negative 10 into a fraction itself. So I have fraction times fraction. Okay. Wait. Did I mess up somewhere? Here. Because a negative times a negative is a... All right, now I'm going to handle the multiplication of fractions. How do you multiply fractions?
Across.
Straight across. Cross
Wait, no,
multiplies when there's an
sorry.
equal sign. Straight across. That's okay. I'm not mad.
That's negative 35, right?
Yep, so 70 divided by 2 is 35. All right. Now I need to add together negative 35 and positive 14. So negative 35 plus 14. We're combining these like terms.
I'm really blind. I thought that said 142. That's why I said it. 252.
So this is a 14z. So I need help. Negative 35 plus 14. Someone that's playing on their phone there. Huh? Negative 21. And then I'm going to subtract the 110 from both sides. So 47 minus 110.
157. Negative. Right? Oh.
Yeah.
Yeah.
Negative 63. Okay. Then we're going to divide both sides by negative 21. And I think we end up with a positive 3. If you've got your calculator app open. Yes? Okay. I have 1 part of my 3-part answer after all of that work.
And that's just one part.
And that's 1 part of the 3. I have to go find the
Can
other
we
2.
finish this one and call it like that section?
Yeah, I think so.
That's just one.
This is a lot.
This is. Okay, so right here, we substitute right here. It's a lot. I really want you to practice and get good at these because then when I hand you the shortcut, let's just stick it in the calculator and have it give the answer, you're going to be like, oh God, this is great. And you're going to do like hundreds of them in like 2 minutes and it's
There's no
going to be
4
wonderful.
by 4, right?
Huh?
There's no 4 by 4.
Yes.
Are you
His
gonna write
question was, is there 4 by 4? Yes.
I should've
There's
known
5
that.
by 5. I
I
have...
think I'm gonna drop out because it would trade school.
Wait, are we going over those 4 by 4 and 5 by 5 this year or no?
No.
Oh, thank
I
God.
don't think you.
Maybe next year.
In fact, the method I'm going to show you, once you start getting into those 4 by 4, 5 by 5, 10 by 10s,
Oh my.
you stop doing them by hand and you literally just put them in the calculator.
There's 10 by
Did you say
10?
10 by 10?
Sure, you could have 100 by 100 if you want. You know your favorite video games
Yeah.
on your phones and on your computers? It makes use of these really big 3 by 3, 4 by 4, 5 by 5, 10 by 10 systems of equations to do stuff with all the little characters and scores and things
Even
in your
like the
video
smallest
game.
command?
Not all of them, but some of them make use of these things in various sizes. I know, right? Which is why I'm going to show you how to do it on a calculator because that's literally what your video games are doing. They're not doing this. All right. So I've substituted, I've multiplied very badly, and then I've realized I need to subtract these fractions. So we're going to go way back, yes? So we're going to go way back to subtraction of fractions. How do you subtract fractions?
Cross?
No, it's
It is a cross, but in order to do that, you must have common denominators.
that.
But really, we want the least common denominators. Do you remember how to get least common denominators?
No.
You have to go down with the key.
I heard that you have to go down and do some stuff, and I heard, not really.
I forgot, when did they teach us that? I don't remember.
Ooh.
That was like in
Second
seventh grade.
Yeah, so the skill that you use to find the least common denominator is actually the skill least common multiple, which you probably should have picked up around 3rd or 4th grade. Maybe 5th. Okay, so somewhere in that time zone.
Can you just make it to 2 and multiply the top by 2 as well to make it even? Because then it would be 22.
Yes, that's exactly what's going to happen.
I think I learned that like in 4th
That's
grade.
just like
What?
how much is that?
You've already got the shortcut because you already feel comfortable with the pattern. Stop, please. I've got a few people that don't know the pattern, and so while you can see it in your head, go ahead and jump to it. But I want to show this out because college algebra, pre-cal, and then kind of toward the tail end of this year, we're going to have to be able to find common denominators of things that aren't just numbers. Stuff that have letters. And how do you do that? Okay? So let's talk least common multiple to get us least common denominator. Least common multiple is you take a number and you start multiplying it by a bunch of numbers and you just jot down your answers. So 1 times 1 is
1,
times 2
2,
times 3
3,
times 4
4,
times 5.
5,
All right, I'm already bored. I'm going to stop. 2 times 1 is
2,
times 2 is times 3 is
6.
times 4 is times 5 is. I'm bored again. I'm
I
going to
got
stop.
lost by like 6.
Now we're going to mark all the ones that they have in common.
2, 4.
Whoops, I missed. Not that one. And now I want the least, the smallest. That one. That is the least common multiple between 1 and 2, and that becomes our least common denominator. And so I'm rewriting my fraction minus fraction with common denominators. I've left the numerators alone because I don't know what they're going to be yet. All right, now to figure out what those numerators are going to be. This bottom is a 2. Do I need to do anything to it to make it a 2?
No.
No, so I'm not going to do anything to the top. Beautiful, I'm done. What do I need to do to 1 to turn it into 2? By multiplication.
Oh, well. Times 2.
Times 2, that's what I must multiply the top to. And 11 times 2 is 22.
So it'll be
Now I can subtract across. Don't change your denominator.
negative 5.
Negative 5?
Negative 5.
Negative 5?
Negative 5?
That's what I'm hearing. What do you say?
Negative half.
Oh, negative half! Look, la sorda no olla.
I was like, why do you guys keep saying -5? Like, just going back and
I
forth.
know, he was like, negative 5? And he was like, no,
'cause I had my
and then
hand
say
over
negative
my
5. And I was like, we have part 2 of our answer.
Yay!
Part
One more.
3, one more.
See, that wasn't that long because we already kind of like.
Yeah. It's found way up there. We need this equation.
Miss, you might be getting all the people a little late.
That's okay. That's all right. I'll give you a due date. That's all right. Calm down. So I'm gonna grab this equation way from the very top. And now I'm going to plug in the value for y and the value for z. And it should give me a value for x.
If you post this one, it's gonna be one funny video.
It's gonna be funny. All right, Yep.
From
This
the
one
top.
at the very, very top. So it was the very first solve for x. Great question, thank you. All right, make sure I'm multiplying properly.
Isn't that a positive though? Positive one?
No.
Here, right?
Yeah.
Yeah, because it's a negative. Yes. And that's why I paused, because I was like, I've done this before and the numbers are different than the first time I did it. What did I
X
do?
equals 4, right?
Yes. I now have all 3 parts to my answer. Yay! So I can write my solution as the ordered triple. It's an ordered triple because order matters. X must come first, then Y, then Z. And order is important on an ordered triple because this, like your ordered pair, is a location. Your ordered pair XY just tells you how far you go left or right and how far you go up and down, yes?
Yes.
Well, an ordered triple is going to tell you how far left and right, how far up and down, and how far toward and away.
Like the lines.
It's 3 directions of movements, not 2. You cannot draw this on a flat sheet of paper. You have to somehow magically levitate and float a point in midair to make it work. Because you have once 3 dimensions. You have a left and right movement, that's your X. You have a up and down movement, that's your Y. And you have a toward and away movement, that's your Z.
And she filled up almost the whole page.
We did almost the whole page? Nah,
Page.
we did fill the whole page.
There's
Look
like,
at
there's like a
that.
spot right there, and then this one right here, and then the bottom.
Ernest,
There you go.
it's the nicest way I've ever seen it.
That's all we had for 3 by 3. Thanks
Bye.
much.
Thank you.